Welcome back. In episode 2, we wrote our login endpoint using TDD on the Ktor server. Today, we will do some test-driven development on the client side. We'll start with failing UI tests for a Compose login screen. We will then implement the smallest UI to make it pass. We will also write failing logic tests for our ViewModel. We'll inject a coroutine scope for testability purposes, and we'll finish everything by wiring everything together. Let's dive in. For our UI tests, we'll write them in the client module. Since we are sharing our UI with desktop, this will be good enough for our application right now. Let us begin by having our Ktor dependencies on the client side. We will add the core client and the engine of choice. In our case, the engine of choice is OKHTTP, since we have our project running on the JVM for both desktop and Android. We will head over to our root settings.gradle file and make sure that our module is included in our project. Then we'll head over to the build.gradle file within our client module. We will start by adding our serialization plugin. Inside commonMain, let us add our Ktor dependencies. Lastly, in our common test source set, let us also add our test dependencies. Compose.ui test will be used for our Compose tests. It's an experimental tool as of writing this video, so let us opt in. After this, we can sync our Gradle files. We have now added Compose UI testing. Now we are ready to go Red Green Refactor for our UI. Let us create a file known as login screen test inside our common test source set. Since Compose UI is experimental, we'll need to opt into the API. Next, let us add our UI tests. We will start with the login screen showing the fields and the buttons that it needs. This is how we'll set it up. Here, we'll set our content to be our text. This will just be a dummy screen. We'll replace it with the real one later. We will check if the username and password nodes exist. We'll also check if the button with the login text exists. Let's run it on the JVM. As we see, our test indeed fails. Let us add 2 more tests for our screen. These UI tests describe the screen we want. 2 input fields, a login button, and appropriate messages for successful or failed login attempts. They will all fail for now, exactly what we want in our test-driven development setup. Let's head over to the green. We will begin by creating our login screen UI skeleton. We'll replace this composable definition in our UI tests. Don't worry if they still fail at this point, because that is exactly what we want. We're about to make them pass. Here is our login screen. Let us now replace it in our test. Once that is done, we'll now add some UI code for our application. We will start by adding an onLoggedIn lambda. This will take in our username and our password, and it will execute a certain operation. For now, we default to returning unit. Next, we will add 2 state variables, one to use our password and the other one for our username. We'll also have another state variable that will be used for the toggling of password visibility. All our items will go inside a column. It will fill the maximum size of the screen with a padding of 24 dp across the horizontal axis. Every item will be centered horizontally, and we'll arrange the items from the center vertically. We'll add a header text which will say welcome back. We'll then add our outlined text field that will be used to receive our username. After that, we will input our password text field. Here, we'll add the value on value change, and all these other parameters. Our trailing icon will use the isPasswordVisible variable to toggle visibility and which icon is shown. We'll also add a button that will contain the text login. Once this is clicked, it will call the onLogin_clicked lambda provided in the param. Let us finally add a preview and look at how our UI is supposed to look like. Perfect. Everything looks as we'd want it. Now that we have added some UI, run the first test for showing the login component. The first test passes. This is the one that shows our components. We want our UI components to be fully testable, and so we will have our screens be dependent on contracts, as opposed to actual implementations. This will give our UI freedom to be tested independently of all other app components. Let us start by creating our ViewModels contract. We will have our UI state stored in a single data class. You could always replace this with a sealed interface or any other way you would like your UI to be represented. We will add a variable which we'll call UI state. This will be a stateflow representation of our current login UI. Then we will add the function login, which will retrieve a username and a password. This is the function that will be called when the user clicks on the login button. We can then refactor our tests by creating the fake implementation of the ViewModel for purposes of our UI test. We will then add some 3 methods, one for emitting success, another one for error, another one for the loading state. We will start by adding a private UI state that will be mutable within the class and will expose the UI state publicly as our contract indicates. You can always override the login method and do your implementation to simulate any other login scenarios that you would like. Our 3 methods simply call the update method from UI state and copies over the previous UI state and updates it with the current one. Now that we have the fake ViewModel, let us refactor our test so that we can have it use the contract as a dependency instead of the lambda expression. We will also add the fake implementations of success and failure scenarios. There we have them. We are emitting success when we press the login button in the first test, and we emit a failure when we press the login button in the second test. You'll notice that the test does not actually compile. This is expected since we are yet to refactor this parameter change in our screen. Let's head over to the login screen to update this and implement the remaining features. We start with the parameter change. The next thing we'll do is we'll collect our UI state from the login ViewModel. After which we will dynamically have our welcome text check if is logged in is true, then we will show a message of welcome and provide the username on the side. If not, it will stick to welcome back. Be sure to replace that text inside your text composable. We will need to update our lambda. Lastly, we will add our invalid credentials text. We've now added the smallest UI that can pass our tests, using a testable through a tiny iLogin VM interface. Run the UI tests. Now they should all be green. Looks like we forgot to give our preview a value for our login VM. Let's add that. I have added a singleton VM that will be used for part of our preview. We can now run the tests once more. There you go. They all pass. Now, one thing you'll have to remember, in my line 39, I also added the username as part of the text that we want to assert exists. Time for our ViewModel login test. We'll start by defining a scope, a dispatcher, and a login VM variable. We will use a test scope and a standard test dispatcher to run our tests. Our first test checks on whether the ViewModel will update state correctly when login is successful. You will see we have implemented a fake API service, which inherits our API service interface. This has a function called login that takes in a username and a password and returns a boolean. I have created the base of this class here, API service, which will have the function, which is a suspend, and it will return a boolean, whether true or false, when you attempt to log in. There's also another class called login VM. I have also placed this in this test just for purposes of us to be able to compile our test. However, this specific one won't compile though, because our login VM contract actually has some methods and variables that need to be implemented. Let's do that quickly. Fantastic. Let's go back to our test. This fake API service just returns a true for our ViewModel. We can construct our ViewModel, provide the API service as a parameter, our dispatcher, and the scope that we will use. Our initial states should be false. Make sure that is clean. We will then attempt to log in. We'll also call advance until idle from within our test scope, so that we can move the virtual clock within our coroutine. After which, we assert that the corresponding statuses are correct. Status for login should be true. State should show that loading is now false, that has been completed. And lastly, there should be no error within our state variable. We do something similar for login failure. Here, we simply set our login function to return false and repeat the processes from the above other test. Then we perform our assertions. Make sure you are not logged in and you're no longer loading. Finally, show the error message that is usually displayed. These are pure unit tests. We control our coroutines with a test scope. We will refactor the location of the API interface and the login VM classes. Now, let's head over to the green and implement the logic in our client. Time for implementation. We'll provide a default scope with a supervisor job within its context. We'll also provide a dispatchers.default as the default for our coroutine dispatcher. Every platform can implement this independently, depending on what they'd like. We also have our API service dependency, which we'll call our actual network call. After which, we override our login method and do some updates. Firstly, we'll set loading to true immediately the user presses login. We will then launch our coroutine that will attempt to log in. If a successful login is shown, update the state correctly. If not, also do the same. We have surrounded all this inside a try and catch block such that in the event of any error, we also update the UI state to reflect accordingly. You will notice that within our login VM file, we have our login request data class. We will use this to provide parameters to our Ktor client when making our network request. Let us create this Ktor API service. For now, let's have it inside our login VM class. We'll refactor that all later and put them in their correct folders. There is our implementation. We simply make a post request to the login endpoint, set our body, set the content type, and check for the response if it's success or not. Success usually ranges from the 200 error codes. We can now run our login VM test and see that everything passes. Perfect. Now, let's put everything together. Our UI and our ViewModel, given that we have also set up our Ktor API service. Let's open our app module, from which let's delete the existing content. Let us add a HTTP client for our app to use. Import all that. We will then need a way to construct our login ViewModel. Since our ViewModel needs the API service, a dispatcher, and a ViewModel scope. This is how I will construct my login ViewModel using a composable. Create a scope, then return the login VM. Provide your scope, provide your API implementation service with the HTTP client that it depends on. Lastly, add a dispatcher. In my case, I want the login calls to be dispatched in the IO thread. We can add our login screen. Provide our ViewModel using the remember login ViewModel function. Let's now run our application in desktop and make sure to run your server so that you can test with the integration on the actual server application. I'll start with my server, have that running. Great. Then I'll run my desktop app. Here it goes. We can search in maybe mail password. So check that. This gives us invalid credentials as expected. We had hard-coded an existing username and a password. So that was user and password. Now we can see we have welcome, but with some blank text. So there is some missing UI. Let's try and add that. In our ViewModel, once the user presses login, we would want to update their username and password here. That's it. Rerun the app. User. Password. And we can see welcome user. Our UI works as expected. Now it's the refactor stage. So we put all our files in the logical folders for organization purposes. As you'll see, I have added my API service into the network package. I have also put my presentation logic into a login folder, and there's also the app in the root of the presentation. Within our tests, I've done the same. Our UI test goes into the login screen test, and then we can always move the login VM test into that section as well. That's the client login flow built with test-driven development. Our UI went in first, then the logic. These were cleanly separated and made our components fully testable. Our next episode is available in a course on Udemy that is dropping on this date. Be sure to check that out. We explore the full chat application from start to finish, including the first 3 episodes that you've seen right here on YouTube. Be sure to go check it out when that drops. A big video announcement coming soon on the channel. That's all for today. Make sure to like, subscribe, and share, and see you in the Udemy course.